एवरीवन, कैसे हो सभी लोग? आई होप सारे अच्छे होंगे। सो आई एम बैक अगेन विद द लेक्चर थर्ड ऑन बाइनोमियल थ्योरम। आई मैं काफी दिनों से वीडियोस नहीं बना पा रहा था जस्ट बिकॉज ऑफ माय कॉलेज वर्क एज वेल एज मेरा एग्जामिनेशन चल रहा था। ठीक है, अभी भी चल रहा है बट इन द मिडल ऑफ द एग्जाम आई एम ट्राइंग टू मेक दिस वीडियोस। ठीक है, तो लास्ट लास्ट लेक्चर में अगर आपने लास्ट वीडियोस देखे होंगे, अगर नहीं देखे होंगे तो यहाँ पर आई टैब आ रहा होगा, वहाँ पर क्लिक करके पहला वीडियोस देख लेना। और डिस्क्रिप्शन बॉक्स में बाइनोमियल थ्योरम का प्लेलिस्ट मिल जाएगा, वहाँ से स्टार्टिंग वीडियो से देख लेना। ठीक है, ताकि आपको अच्छे से समझ में आए कि बाइनोमियल थ्योरम कैसे होता है एंड हाउ डू वी नीड टू कैलकुलेट, व्हाई डू वी नीड इट। ओके, सो शुरू करते हैं थर्ड लेक्चर से। सो हम लोग स्टार्ट करेंगे वहीं से जहाँ पर हम लोग खत्म किए थे। तो लास्ट लेक्चर में हम लोग ऑलरेडी पढ़ रखे थे अबाउट द जनरल टर्म, अबाउट द ग्रेटेस्ट बाइनोमियल कोफिशिएंट एंड टॉपिक्स रिगार्डिंग इट, और उसके ऊपर से हम लोग क्वेश्चन भी सॉल्व किए थे जो जेई मेंस और जेई एडवांस में आ रखे हैं। आज का लेक्चर हम लोग रिकैप से स्टार्ट करेंगे एंड इसके साथ हम लोग देखेंगे द मोस्ट इंपोर्टेंट कॉन्सेप्ट ऑफ ग्रेटेस्ट टर्म ऑफ एनी बाइनोमियल एक्सपेंशन। तो शुरू करते हैं आज का टॉपिक। So today's topic will be binomial theorem and the question on general term. Okay, तो जनरल टर्म वाला जो पार्ट था वो लास्ट लेक्चर में रह गया था। ठीक है, तो हम लोग शुरू करेंगे जनरल टर्म से। ऑलराइट, एंड उसी के उससे पहले थोड़ा रिकैप ले लेंगे ताकि आपको अंडरस्टैंडिंग और कंटिन्यूटी बना रहेगा। ठीक है, तो शुरू करते हैं। नाउ अ बेसिक small recap. Okay, now by the term binomial, the binomial terms basically implies that there are two basically independent terms in a particular expression. Okay, so like two independent term in an expansion, now there's two independent terms be x and y, and they are raised to some integer power or positive integral power, and this particular expression is known as a binomial expression, and we basically write the expansion of this particular binomial expansion as sigma r is equal to 0 up to n nc ncr x raised to the power n minus r and y raised to the power r. So this is the basically the binomial expansion of any given variables. Okay, so this was the basic thing that we started off with the binomial theorem. Okay, and one more thing I wanted to clarify out is that this ncr, which is basically the binomial coefficient, or it is known as the combinatory coefficient. So this is basically given as n factorial divided by n minus r factorial divided by r factorial. Now many in time there will be some situation where this binomial coefficient is not written as ncr, whether it is written as nr. Okay, like this fashion. So this also means nothing but the binomial coefficient, that is ncr. Okay, so many in time in many international mathematics books you will find this particular notation. Okay, I hope this particular notation is clear. Okay, now I have already talked about like how this binomial expansion is basically coming upon. Okay, now after this we studied about a general term. Now we saw that if we have to find the r plus 1 term, that means we basically write it as t r plus 1, and we basically write it as nc r x raised to the power n minus r, okay, and y raised to the power r. Okay, so this is how we basically represent the general term of any binomial expansion. Okay, so with this I already talked upon the other important things, that is basically the number of terms in the expansion. Okay, so we have already studied that in this particular expansion the number of terms present will be basically n plus 1. Okay, now similarly you can talk about other important things is basically when we have in a trinomial expansion like this fashion a plus b plus c whole raised to the power n. Now in this particular way, if we have to find out the number of terms, basically I will derive this particular expression for how we are getting the number of terms in this particular multinomial expansion. Okay, this basically comes from the relation of permutation and combination. Okay, but you can directly remember this particular results. Okay, so you can do for this particular expansion you can also write this expansion as something as a plus b plus c whole raised to the power n. Okay, and when you basically do this particular expansion, and when you take this particular term as one term and this particular term as another term, you will basically get n plus 1 terms involving a plus b and c. And in the a plus b expansion also you will also get that in the coefficient of n or n minus 1 or n minus 2 you will also get again n plus 1 n minus 2 terms. So that will basically add up like a lot of terms, and if you have to remember the total number of terms involved in here, so you can directly remember it as, okay, you can remember this particular expansion as this will be basically n plus 1 plus n plus n minus 1 and this fashion up to 1. So this is basically nothing but n plus 1 into n plus 2, okay, sum of all the natural numbers n plus 1 into n plus 2 divided by 2. So this will be the basically the total number of terms in this particular expansion of this multinomial expansion. Okay, now there will be some short question regarding this also, but stay tuned with it if you want to know how this particular derivation comes. Since see, you can do this derivation by this particular fashion by converting this multinomial into a binomial. Also you can do this particular derivation by the use of permutation and combination, and that I will teach when I will be talking upon the concept of multinomial theorem, okay, which will come up in the following lectures. So stay tuned for that. Okay. Also, we talked about other important concepts regarding the middle term. Okay. So we talked upon the middle term. Okay. So what we saw in the middle term questions, that if n is basically odd, then we basically have n plus 1, which is even number of terms, and that means there will be two middle terms corresponding to it. Two middle terms, and two middle terms will basically be the n plus 1 by 2th term and the n minus 1 by 2th term. And if the value of n is if the value of n is even, that means we have n plus 1 term, that means there is odd number of terms. For that particular case, we have only one middle term, and that particular middle term is given as n by 2 plus of 1th term, n by 2 plus of 1th term. So that's how we basically calculate for the middle term whose binomial expansion coefficient is basically even or odd. Okay, I hope this particular thing was clear in the last class. Okay, and also we talked about other important concepts like the how to calculate the rth term from the front as well as the rth term from the beginning. Okay, that means the rth term from the beginning as well as rth term from the end. Okay, what we saw in this particular concept, when we have to calculate the rth term from the end, we basically replace, in place of x and y, we basically interchange them in order to get to the rth term from the end. Okay, so that's how we basically calculate for that particular questions. Okay, you don't have to remember any particular formula. For example, you have to calculate the rth term from the end, that simply implies the rth term from the beginning of the expansion when you change the independent variables. That's how, that's simple it is. Okay, now the next thing we also studied about is the greatest binomial coefficient. Now, the greatest binomial coefficient is different from the greatest term, and in the greatest term we will basically see in today's lecture is basically the whole term involving that binomial, okay, of that particular expansion, whereas the greatest binomial is basically the binomial coefficient which is the greatest one. So what we saw in the last lecture regarding the greatest binomial coefficient, that if n is even value, then the greatest binomial coefficient is given by, for example, we have the expansion of let me take it like uh, so if we have the expansion of 1 plus x to the power n, or maybe whatever expansion it is, it raised to the power n. So if n is even, what we saw that the binomial greatest binomial coefficient, okay, so the greatest binomial coefficient was nc n by 2. Okay, nc n by 2. So that was the greatest binomial coefficient. Now we have also seen the proof of that this particular thing in the previous lecture only. So if you haven't watched the previous lecture, please watch the previous lecture, then only you will be able to continue this particular lecture. And similarly, if n is basically odd, okay, then we have basically two binomial greatest coefficient, and that are nc n plus 1 by 2 comma nc n plus 3 by 2. Okay, so these are the basically two greatest terms. Okay, these are the basically two greatest terms. All right, so also we saw about another important concept regarding the fractional part of a function. Okay, that was basically simply the remainder theorem type problem. Okay, so that was all what we discussed in the last lecture. So in today's discussion, let us start with taking up some question. Okay, now I took up this particular question from the JEMS previous year question only. So it says, in the expansion of 2x square plus 1 by 2x whole raised to the power 11, we have to find for the coefficient of x to the power 10 and the coefficient of x to the power 7, and whatever coefficient we found out, we have to find the absolute difference between the coefficient. Okay, so let us calculate and firstly see what will the expansion of this particular binomial expansion look like. That this particular expansion of the binomial will look like r is equal to 0 up to 11 cr 2x square whole raised to the power 11 minus r. Okay, now 1 by 2x whole raised to the power r. Okay, so this will be the basically the binomial expansion of this particular term will look like. Now from this particular we have to find for the coefficient of x to the power 10. Now we have already solved this type of problem when we basically need to calculate for the coefficient of x to the power some power. What we basically do, we firstly find out for any general term, we try to find out or what is the variable power of x. Okay, so in the general term will basically look like 11 cr 2, that is basically, let me take out the constant part outside. So we have 2 raised to the power 11 minus r and 2 raised to the power minus r, that will make 11 minus 2r. And similarly the x raised to the power 22 minus 2r, and from here it will become minus of r, that means 22 minus of 3r. So this is the x raised to the power 22 minus 3r. So from here we have to look for the power is 10. When the power is basically 10, that means the coefficient of x to the power 10. So from here if we look from here, we'll basically get it as 3r is equal to 12. Okay, 3r is equal to 12. That means the value of r will be 4. That means the fifth term of this particular binomial expansion will have a power of x raised to the power 10. Okay, and similarly, if we solve for x to the power 7, okay, x raised to the power 7, or the coefficient of x raised to the power 7, we'll basically get it as 22 minus of 3r is equal to 7. So from here, if I solve, this will be 3r is equal to 22 minus 7, and 22 minus 7 is equal to 15. This will give me the result r is equal to 5. That means the sixth term of this particular binomial expansion will give me the coefficient of x raised to the power 7. Okay, so from here we basically got the terms which basically contain this particular coefficient of x. Now we have to find out for what is the term it is. So corresponding for x to the power 10, that means the term is the fifth term. So the fifth term will basically become 11c 4, 2 raised to the power 11 minus 8 is basically 3, and the sixth term will become 11c 5, okay, 2 raised to the power 11 minus, and this will be 11 minus 10, and there is 1. Okay, so from here we have to basically subtract these two terms. That is, we have to take out the absolute difference of t5 minus, okay, I am representing t5 without the coefficient, okay, because the coefficient will be there, that is the term 5, actual term 5. Okay, so from here this will be the difference of the absolute difference t5 minus t6. The absolute difference is equal to 11c4 8 into 8 minus 11c5, okay, into 2. So from here I can take 2 common out, okay, or if we don't want to take this 2 common out, because the answer is not basically in the form of common, or maybe let us solve it. Okay, so that will be 11c4, 4 into 11c4 minus 11c5. Okay, now how to solve for this? Now 11c4, now we have already seen a shortcut, okay, regarding solving of 11c4. What we basically need to do is basically continuously multiply up to the number of terms is achieved, what is in the lower suffix. Okay, that is, you have to basically continue multiply 4 times. This will become 11 into 9 into 8 into 9, okay, and divided by 4 factorial, that is 24. And from here if I cancel out these terms, this will be 3, and this will be again 3, so this is 30 or 330. Okay, so this will become 330, so this term is 330. Okay, and 330 into 4 is equal to, okay, or we directly multiply with 8 only, so 330 into 8 this will become 2640. Okay, so this will become 2640. And from here, okay, and for this particular term, that is 11c5, and 11c5 is basically equal to 11 into 10 into 9 into 8 into 7 divided by 120, that is 5 factorial. So from here if I see, this will become 14 into 3. 14 into 3 is basically 42, and 42 into 11 is equal to 262. Okay, 462, sorry. So from here you will get basically this result as 462. Okay, and 462 into 2, so this term you will get it as 462, and 462 into 2 is basically 924. Okay, 924, and this will become 2640. So 2640 minus 924, the answer. So if we see the 2640 minus 924, the answer will become, the last digit will be 6, this will be 2, this will be 16 minus 9 is basically 7, sorry, 16 minus 9 is equal to 7 only. Okay, I'm correct. Okay, 1726. Okay, now 1726, we have to look for the where on this particular terms the last digit is basically 6. Okay, that's how you basically reduce the number of calculation, or maybe you can use your calculation power also. Okay, so what we know that 11 ki power 3 is basically 1331. Okay, and minus 11 will never become the last digit as 0, so that means this particular thing can never be the answer. Okay, so the option A can never be the answer. Similarly, 3 raised to the 13 raised to the power 3. Okay, so what we know about 13, the 13 square is basically 169, and if you multiply again with 13, so last digit will become 7, and 7 minus 3 is equal to 4, but we need 5 over here. Similarly, 12 raised to the power 3, so what we know, 12 square is 144 into 12, so last digit will become 8. Okay, and similarly 8 minus 2, now this can have the last digit as 6. Okay, so that means this is the only favorable answer that I can see, because 10 cube minus 10 is basically 990. Okay, so cannot be the answer. Sorry, this cannot be the answer. Okay, so the only correct option in this particular question is option number C. That means the Correct option is option C. Okay, I hope you have got this particular question. Okay, this is a very pretty simple question. And how I solve this particular question is basically you also need to apply these particular types of tricks in order to get to the answer as fast as possible. I hope this particular concept was clear. Okay, now let us move to the another important question which involves the concept of coefficient. Okay, now this is a J advanced question. Now this is a wonderful question. Okay, so if we firstly talk about this particular question, what is said in the question, we have to find for the coefficient of x raised to the power 11 in the expansion of this particular. There are, now if you look at this particular question, there are basically three binomial expansion which is multiplied with each other. Now this is the beauty of J advance. Okay, now basically you are actually calculating in mains level question, you are basically calculating only for one binomial, and in J advance you have to calculate for the product of all the binomials. So that's the beauty of this particular question. Now you have to think just little bit more. Okay, so if you look at this particular question, you will see this is x 1 plus x square keep power 4, 1 plus x cube keep power 7, and 1 plus x keep power 4 whole cube power 12. Okay, so from here we have to find for the coefficient of 11. Now, if we see in this particular binomial expansion, now whatever expansion of x power will be some format of 2 times of an integral number. That means 2 times of integral number, let that integral number be a. So I can write this, that this particular expansion will have the coefficient or the x raised to the power something as 2 times of a. Okay, so from here, if I get the coefficient of x raised to the power as 2a, so similarly from here we will get the power of x as, that is 3 times of some integral number, let that be b. And similarly from here we will get the that power form as 4 times of c. Okay, now that c with another integral number. Now why I am adding this all? Because whatever coefficient, yeah, we know this particular formula theorem or the basic rule of algebra, that is x raised to the power m into x raised to the power n is simply equal to x raised to the power m plus n. So for this particular reason only I am applying this particular addition, and then if this particular thing is equal to 11, that's what we need to find this particular question. I hope this particular discussion is clear. ठीक है, तो अगर आप देखोगे I am talking about the very basic things only. Okay, so if you see this particular question, the J advance only talks about basic things. If your basics are clear, then you can definitely approach any particular given type of question. ठीक है, so from here if you look at this, so let me go on putting the values. Now you cannot directly solve this particular, can you solve this particular equation? Now if I say you don't need to solve this particular equation, but you need to look for all the possibilities or what can be the possible values of a, b and c. So let me try on and go on putting on some values and check for it. So if I put a is equal to 1 and b is equal to 1, what will I get? This is 5, and 5 plus 8 is equal to 13, or 5 plus 4 is equal to 9. That means this cannot be a possible case. Similarly, if I take a is equal to 2, a is equal to 2, that means this will be 4. 4 plus 3 is basically equal to 7, and 7. And if I take c is equal to 1, then this will become an 11. Similarly, if I take the value of a as 2 and b as also equal to, so a is equal to 4, 4 plus, and this value if I take b as 2, that will become 10, and 10 plus this we can never be equal to 11. Similarly, if I take b value as 3, what I will get? 4 plus 3, 4 plus 9 is equal to, so what I will get, 4 plus 9 is equal to 13. That can also be not the case. Okay, so if I look at the solid cases, okay, for a corresponding to 2, that is 4, 4 plus 3 is 7, 7 plus 4 is basically equal to 11. That means b is equal to 1 and c is equal to 1. That can also be another possibility. Okay, and other possibilities if we look at, that is value of a is equal to 2 and value of b is equal to 3. Sorry, value of a is equal to 1. Okay, value of a is equal to 1 and b is equal to 3 and c is equal to 0. That will also make up the case when the sum is equal to 11. Okay, now regarding all these three terms only, the possible sum is basically equal to 11. Okay, in except all other cases we are not getting the sum as 11. Okay, so I hope this particular thing is clear, and that's how basically firstly approach this particular basic thing. Okay, now corresponding to this particular conditions, let us try to find out what will be the terms. Okay, so that we get to the coefficient. So the first case, if I solve for the first case, that is a is equal to 2, b is equal to 1 and c is equal to 1, what does this thing implies? This thing implies that x raised to the power 4 from the first product term, okay, and x raised to the power 3 from the second product term, and c is equal to 1, we basically x raised to the power 4 from the third product term. Okay, so x raised to the power 4 is possible. Yes, so what will be the value of x raised to the power 4? That means this is possible when the r value is equal to 2, that we can get by the mental calculation only. So for this particular term, what we will see, that this will become 4c2 4c2 into 1 raised to the power 2 into x square whole raised to the power 2, that will become, make it at x to the power 4. So what we need is basically coefficient of x to the power 4 from here. Okay, similarly, now what we need to do for this particular number, we have to basically multiply it in order to get to the terms of the coefficient. Okay, into, now for getting this b is equal to 3, can we get b is equal to 3? Now think of this particular term, can we get b is equal to 3? I mean b is equal to 1, that means basically x raised to the power 3. So if we look at this particular second expansion, 1 plus x cube whole raised to the power 7, so the terms you will get basically 7cr 1 raised to the power 7 minus r into x raised to the power 3 into r. Okay, now 3 into r, that means when the r value is equal to 1, you will basically get for x raised to the power 3. So that's how you put over here, that is 7c1 into 1 into, for getting this value of cs1, that means x to the power 4. So you will also get it as, it will also get when this will be 12c, sorry. So if I like this expansion, this will be x to the power 4 into r. So in order to get x is equal to 4, that means we have to put r is equal to 1. So this will be 12c1. Okay, plus other cases. Okay, now let us look for this particular case. When a is equal to 2, when a is equal to 2, b is equal to, so we have calculated for this case. And this next case is basically, why did I write it 2 times? Okay, I'm sorry, I wrote this 2 times. Okay, now if you look for other possibility cases, okay, I guess I missed some possibilities. The one important possibility is 4. 4, a is equal to 4, that means 8. 8 plus 8 plus 3 is equal to 11. Okay, so this is a is equal to 4, b is equal to 1, and c is equal to 0 is also a possibility. Okay, it's also a possibility. This possibility I missed up. Okay, so let us calculate for this particular possibility where a is equal to 4, b is equal to 1. So a is equal to 4 will correspond to x raised to the power 8. That means 4c4. Okay, that simply means 4c4. Okay, and for b is equal to 1, this will basically mean 7c1 plus, and c is equal to 0, it will basically means the 11c0. Okay, plus now let us look for this term, that is a is equal to 1, that is x square. So if I look for the 4c1 term, will be the x square, that is 4c1. Okay, 4c1 will be the first term of when we get the, from the first product we get the x square, and for the second one we have to basically find for b is equal to 3, that means x raised to the power 6, and x raised to the power 6 is possible when r is equal to 2, that means this will become 7c2 into c is equal to 0, that will basically become 12c0. So if we add all these particular terms, that is 4c2 value is basically equal to 6, 6 into 7 into 12. Okay, plus this will become 7 plus this is equal to, okay, if you look this term, this is equal to 4 into 7c2 into 7 into 6 divided by 2, that is basically 21. Okay, so this will become 84 plus 84 plus 7 plus this term will become, this is 72 into 7. Okay, 72 into 7 is basically 14, and 504. Okay, so this will become 504. Okay, I believe I haven't done any mistake. Okay, because okay, let us check whether I have done any mistake or not. Okay, regarding, I'm very sorry, I missed another very important case. Okay, another case, that is basically when the value of b is equal to 1 and c is equal to 2. So this particular case I missed out. When value of a is equal to 0, b is equal to 1, and c is equal to 2, because c is equal to 2, that will basically 8 plus 3 is also equal to 11. Okay, so I missed out this case. And in the case when this is basically 8 plus 1 is equal to, so from this particular case, okay, and regarding the remaining cases, everything is correct. Okay, and this particular case when b is equal to 3, so this will become 3. Okay, I made a mistake. Okay, this will be 7c3. Okay, I'm very sorry, this will become 7c3. So 7c3 is equal to 7 into 6 into 5 divided by 6. So 6 and 6 can cancel, this will be 4 into 35. Okay, so this will become 4 into 35. My mistake is, I'm very sorry for that. Okay, and also another case when basically you have these particles, when b is equal to 1, c is equal to 2. So b is equal to 1 will correspond to 7c1 into c is equal to will correspond to the case when 12c2. So 12c2 value is equal to 66. Okay, if you calculate 66 into 7, so this will become, so this will be give me, okay, so this will not be 184, this will become 140. Okay, 140 plus 7 plus 100 504 plus this particular number. This particular number will give me 4 and this will become 462. And if you add this all these four numbers, you'll basically get 113 1113. Okay, so that's the right answer of this particular problem. That is basically option number C. Okay, I hope this particular question is clear. Okay, so this is the way you have to basically approach J advanced question. Okay, the question are not very difficult, but it is basically tricky, like how you are basically having patience in solving this particular question. Okay, so it is all about the matter of patience. That's what. All right, so I hope this particular thing is clear, and you should not make this particular mistakes. Okay, I made a mistake. Okay, I'm sorry for that. And the next time you must remember that you need to consider all the cases. And how will you know that all the cases are considered? You have to basically check for all values of putting. Now in exam kind of situation, you basically are in a kind of a tension kind of a situation. Okay, so you might have a chance of missing out these particular types of possibilities. So how to prepare for that? You have to basically practice lot number of these types of problems. Okay, you have to practice for these types of problems in your when you're practicing in your home. Okay, so I hope this particular thing is clear. Now let us move to the today's topic, that is a topic on greatest term of expansion of binomial expansion. Okay, so the greatest term of binomial expansion, if we look at the greatest term of the binomial expansion, we basically get like this particular thing as, so for example, okay, so the greatest term of a binomial expansion. So let me write that binomial expansion firstly as 1 plus x raised to the power n. Now in this binomial expansion, we will basically have the terms as r is equal to sigma of r is equal to 0 to n, NCR, okay, NCR 1 raised to the power n minus r into x raised to the power r. Okay, so this will basically the all the terms. So if I talk about that in this particular term, the tr plus 1, okay, and tr plus tr and tr plus 1 with the rth and r plus 1th term. Okay, so if I say that this is basically that the tr and tr plus 1 are resembling the rth and the r plus 1th term. Now if I say that the tr plus 1th term is basically numerically, okay, numerically the greatest term, okay, numerically the greatest term. So what I can say that if it is numerically the greatest term, then the modulus of this particular term will be greater than t of r. Okay, so from here, if I solve for this particular thing, is that t of r plus 1 divided by t of r is equal, greater than or equal to 1. I can write this as greater than equal to. Okay, so from here, what I can see that if I solve this, this will become NCR divided by NCR minus 1 into x. But I'm neglecting the coefficient 1. Okay, so from here I will get this particular thing as this particular result, that is a NCR divided by NCR minus 1 should be greater than or equal to 1. And we have studied from the properties of the binomial coefficient, with that is NCR divided by NCR minus 1 is nothing but n minus r plus 1 divided by r. Okay, divided by r, and there will be a term. Okay, so if I want to write the term of x, I can write it as x and modulus of x. Let me write this modulus of x just to be in a safe zone, so that you are basically not missing out with the sign. Okay, but you basically need to look for the numerically greatest term. That means which basically implies the numerical greatest means basically the term with the greatest value or the magnitude. Okay, so from here what I can talk about is this particular, we got this particular kind of number. Now from here if I cross multiply terms, and if I look for what will be the value of this term r, I can cross multiply and I will get the value of r. R will be some number which is less than n plus 1 divided by 1 plus mod of x, 1 plus mod of x whole into mod of x. Okay, so this will be basically a number which will come out, that is n plus 1 divided by 1 plus mod of x into mod of x. So from here, what we basically do, that if we substitute for the value of n and x, we basically get a number. Okay, we basically try to get a number or the range of r, that is r is basically equal to. So if we rewrite this particular number, or what is basically known as a short term, okay, or the short trick. Okay, so if you look at this particular thing or as a short method, okay, so what I basically wanted to imply is that whenever we basically get to the value of n, and if we are getting the value of r, we can look for the value of r from here, and if we have the value of r, we can directly put in this particular values and calculate for the greatest term. I hope this thing is clear. Now, what thing you need to remember in mind is basically very simple. That you basically calculate a term known as m. Okay, and this particular term n is will be given by n plus 1 divided by mod of x. Okay, divided by mod of x, or you can put the mod at the end also. Divided by mod of x, or you can put this mod at the end and in whole into x and take a mod of this. So if you take this particular value and there will be a positive number will coming out. So if m is an integer, then the tm and tm minus 1, then t of m and t of m minus 1 are equal, and both are okay, and both of them are the greatest term. Okay, and similarly, if the value of m is not an integer, so if m is not an integral value, okay, and if the value of m is not an integral, then we basically do this particular thing. Then t of greatest integer of m plus 1 is the greatest term. Okay, so this is the everything that you must remember in order to solve this question. Now this particular greatest term concept, I explained it by saying it, you take a number which is plus of f and minus of f. That means the r value will lie from m plus f to or less than equal to m. So that particular n-counting term will be basically be compensated by this particular reduction factor, because we basically need to get a integral number, okay, from here. So if m is not an integral, then take the greatest integer, add plus 1, and then basically this particular term is the greatest term, okay, and this particular term is the greatest term. I hope this particular thing is clear. Okay, so now in many time question you will find this will come like this particular fashion, that is x plus y ki power n, and look for the greatest term of this. So for this particular situation you can also convert this into of this particular form, where that is 1 plus x raised to the power 1 plus x raised to the power n of this particular format. Okay, so for doing so you basically take x raised to the power n common out from here, and this will become 1 plus y by x whole raised to the power n, and from this particular value you basically do the same thing that you did for the previous case. I hope this particular thing is clear, and let us take an example to illustrate what I want to say. Okay, so I have a question over here. Okay, now there is a very pretty simple question that is basically in the expansion of 3 plus 2x, okay, 3 plus 2x whole to the power 50, okay, where, so find the greatest, numerically greatest term, okay, numerically greatest term, NGT. So you have to find for NGT where the value of x is equal to 1 by 5. So find the numerically greatest term of this particular expansion where the value of x is equal to 1 by 5. So what I said, you have to basically do nothing but simply calculate a number called as m, and that is basically calculated as n plus 1 whole into x divided by 1 plus x, and take the mod of that. And if you calculate for this, you will get it as 51, sorry, this will become 51, this will become 51, okay, 51 into, from here this will become 51 into, and for this particular situation what we have seen that in many situations there will not, the expansion will not look like 1 plus x to the power n, but it will be given as x plus y to the power n. So what we have to basically do before doing all these things, we have to take 3 common, and also 3 by 2 also common, okay, so that you basically get 2 from here. So that means this term will become not 3 by 2, but what I tried to say is take 2 also common out from here. Okay, 2 also take common and 3 also common. So if you take 3 common from here and firstly take 2 common from here, then this will become, this term will become, if you take 2 from a 3 by 2 plus x raised to the power 50, and this will become 3 by 2 whole raised to the power 50 plus 1 plus 1 plus x raised to the power 50. Okay, so from here the value of x is basically looks like the value of x, or you can do this particular fashion that x is equal to 2 times of x, you consider it as whole as x. So in place of ax you put it at 2x, and x value is equal to 5. That means you basically put this particular number. Okay, now I did a mistake also over here, so you have to divide by 3 also. Okay, so this particular number, you, instead of taking this 2 common out from here, you can keep this 2 also. Okay, so in that particular situation you have to calculate it as 1 plus 2x by 3, and this particular term you have to consider it as a single entity. So from this particular single entity we have to write from here into 2x by 5, and also from here also we have to write it as 2x plus 5 divided by 5, sorry, 3, not 5, it is should be 3, I'm sorry. this will be 3. Okay, so from here you will get in this number as 51 into 2 by 3 into 1 by 5 whole divided by 1 by 2 by 3 into 1 by 5 and this modulus of that. Okay, so if you calculate this value will come out as this value. If you solve for this particular value, you will see the value will come out it as if you solve for this, okay, so you can solve it easily, that this value will come out as, okay, so if I calculate this is 15 plus and this is 17 and 17 by 15 and this will become 15 in the denominator and this will become 104 102 by 17 and that 102 by 17 is equal to 6. Okay, so from here the value of m is an integral and integer value and it is equal to 6. So in this particular case there will be two terms which will have the numerical greatest term or which will have the numerical greatest value, that is basically the term 6th term and the 5th term. Okay, so from here if you have to calculate or in this particular question or you have to say that which terms are basically the greatest term, you will say that the 6th term. Okay, if you look for this 6 is the value of x r is equal to, or I mean to say the value of m is equal to 6, so that means r is less than or equal to m. So from here you can say that m value is equal to t of r term and the greatest, sorry I made a mistake over here. Okay, this will become t of 6 and t of 6 plus 1. Okay, that means basically the 7th term and the 6th term will be the greatest term. Okay, the 7th term and the 6th term will be the greatest term. All right, so you have to look for that particular situation only. Okay, so just the thing you have to remember, you can remember it as, okay, t of r and t of greatest integer of r plus 1 are the both the greatest integer greatest numerical term. Okay, numerical greatest term. So from here you basically got two terms which is the greatest numerical terms. Okay, I hope this particular example was clear. Now, based on this example, there is another important question which came up in your JEE Mains, which is very similar to this particular problem you solved just now. So, if you look this particular problem, if you take 3 out from here, this will become 1 minus 2 by x, 2x by 3 whole raised to the power 9. So, from here, you will get to the greatest term. In this particular question, you have to only look for the greatest term, not the value of the greatest term. So, I can neglect the 3 also, okay, in order to find the greatest term. Okay, which particular term is the numerical greatest term. So from that particular situation, if you look at, if you if you see the, if I calculate the value of m, this will become 9 plus 1 whole into 2 by 3 into 1 divided by 1 plus 2 by 3 and take the modulus value of this will become 10 into 2 by 3 whole divided by this will become 5 by 3. So if you cancel 5 by 3 cancel and this will become 4. So the value of m is basically, so the value of m is an integer value. So from here you will get basically two values corresponding to the numerical greatest term, that is basically the 4th term and the 5th term. Okay, I hope this particular discussion was clear. Okay, it was very pretty simple. Okay, so if you get an integral value, you have to basically, you will get basically two terms, okay, corresponding to the numerical greatest term. Okay, so with this I come to the end, okay, of this today's discussion of greatest terms of expansion. I hope the recap was clear. So let us end this today's lecture. Thank you.